Find a polynomial function of degree 4 with real coefficients given a complex 0, a leading coefficient, and a graph. Write P in factored form as a product of linear and irreducible quadratic factors. Now first off, by looking at this graph, I can see an x-intercept. X equals 1 is a 0. And because it touches, not crosses, it's of even multiplicity. So that means it's either an x minus 1 squared, or maybe it's an x minus 1 to the 4th or to the 6th. It's one of those in the polynomial. Now, for the other two, we have x equals 2 plus I, but we also have x equals 2 minus I. They always come in conjugate pairs, complex conjugate pairs, if we are going to end up with real coefficients. So this is x minus 2 minus I times x minus 2 plus I. Those are 0, so the product would be 0. If I multiply this out, I will get x squared minus 4x plus 5 equals 0. Now I did that very quickly, but that's from experience. Just go through, x squared minus 2x plus ix minus 2x plus 4 minus 2I minus ix plus 2I minus I squared. Now this last term, minus I squared, is plus 1. And all of that will work out to be x squared minus 4x plus 5. So I believe we have our final answer already. P of x equals, it needs to be degree 4. This x squared minus 4x plus 5 is 2 of those degrees. And so it's this version of the x minus 1. It's the squared. This is degree 4. And we want a leading coefficient of 1/5. That is the polynomial in factored form as a product of linear and irreducible quadratic factors with the given leading coefficient of 1/5. The reason why the leading coefficient has to be 1/5 is if we were to plug in 0, I would get 1 times 5. I would get 5 divided by 1/5, which is 1. I get the y-intercept of 1. So matching this graph, I could have also found the 1/5, knowing the y-intercept is going to be 1. But that's why it has to be specific 1/5 to match up the y-intercept.